Today we're taking another more thorough look at this thing. It looks like Jetson series SBC, it swims like Jetson series SBC, it doesn't. And I haven't heard it quaking either, but obviously it's not Jetson. It's Luckfox Omni3576. I'll do my best to compare its AI and machine learning performance to that of Raspberry Pi 5 and Jetson Orin Nano. Run a few more examples of on-device LLM inference, including multi-modal inference and inference server applications. Finally, I'll check the power consumption of the boards. That last part turned out to be very interesting. Let me start with a disclaimer I should have put in the first video. This is not meant to be an uber powerful inference server for large language models. That video had a lot of positive feedback. The like count right now is more than 1,500. But inevitably there were people who misunderstood the words I put in the title. Single board computers are ultimately the developer boards that are used for prototyping and DIYing things like robots, automation systems, media players, and so on and so forth. They are meant to be small and power efficient, while still enabling people to run the tasks suitable for the edge devices, in this case smaller language models. Which brings us to the question, what can we do with the models that run on a board like this one? Definitely more specific applications rather than a generic chatbot. Acting on the context of the image from the camera or parsing speech into action comments. Domain-specific retrieval augmented generation as well. Those are the tasks 2 or 3 billion parameter models can handle pretty well. But how fast exactly we can run those applications? I benchmarked 3 models. Gemma 2 billion parameters, Llama 3.1 8 billion parameters, and visual language model Qwen 2 VL 2 billion parameters. On the 3 boards, using the methods the most optimized for a specific board, and gathered the results for you. Specifically, llama.cpp was used for benchmarking Raspberry Pi, MLC framework for Jetson Orin Nano Super, and RKNN-LLM for Omni3576. Let's discuss what we see here. First of all, RKNN-LLM provides benchmark numbers for the models, but does not provide the script for how they did those benchmarks. With an adequate 3 ampere power supply and after setting CPU and NPU frequencies to maximum, I could only achieve around 70% of the numbers they have in their benchmarks. For example, Gemma 2 is supposed to run at 8 tokens per second, but the best I could get is 5. Contrary to my own estimation before, that puts Omni3576 in roughly the same category as Raspberry Pi 5 as far as the inference speed is concerned. The caveat here is that we only use NPU for inference on Omni3576, which leaves us with all CPU cores free to do whatever else we need to do. While for Raspberry Pi 5, I have used 3 out of 4 cores to just run the inference. Omni3576 is definitely not as powerful as Jetson Orin Nano, but we knew that already. The theoretical difference is 6 versus 67 tops, so slightly over 10 times. In practice, it translates to around 7 times average inference speed difference, as you see in Gemma 2 benchmark. All of these are just numbers. How fast is it really in human terms? Let's run a few more examples to get a feel of it and also see what these models are capable of. Jetson Orin Nano feels ultra fast, faster than human writing, reading or speaking speed for all the models I tested. One of the cases where you might want to go even faster is code generation. Pi 5 and Omni3576 are quite similar in terms of inference speed. Gemma 2 billion parameter model feels responsive since the token generation speed is close to twice of reading speed. Llama 3.1 8 billion parameters is a bit sluggish. You really have to wait a bit for the final answer. The visual language model, Qwen 2, takes some time to process the image, but after that, the token generation speed is slightly faster than of Gemma. If you plan to run your system off the battery power, the power consumption can be a real problem. Trust me on that one. My next video is taking longer than I wanted exactly because of those power issues. Let's measure the power draw in amperes at the peak during the inference benchmarking for all the boards. Omni3576 is extremely efficient, since NPUs do not only accelerate the inference, they also allow us to run mathematical operations more efficiently than CPUs or GPUs. Raspberry Pi 5 draws twice as much current as Omni3576. And Jetson Orin Nano Super? Well, best to get your big batteries ready for that one. The models that were tested today are on the larger side. If you think you can do it with even smaller models, take a look at the video where I used Hugging Face tiny small VLM to turn Raspberry Pi into a talking camera.